processed in the digestive system into a form that can pass from the tube into your bloodstream. This process is called digestion. Digestion is the process by which food is broken down into smaller and smaller pieces, eventually into small molecules that can pass from the digestive tube into the bloodstream. Food digestion begins in the mouth. The teeth, saliva, and tongue help in the digestive process. The teeth bite, cut, and grind the food. Humans have 3 types of teeth. The incisors cut the food into pieces. The canines tear the flesh apart. And the molars chew and grind the food. Chewing not only breaks food into smaller pieces, but also helps mix the food with saliva. Saliva contains digestive enzymes which change starch into sugar. You must have observed that rice and crackers develop a sweet taste after being chewed for some time. This tells you that salivary enzymes are at work. The salivary secretions also provide lubrication for chewing and swallowing food. The tongue, as you know, is an organ for tasting. Taste also stimulates digestive glands to secrete enzymes. In addition, the tongue helps move the food around the mouth for chewing and swallowing. The following changes in food happen in the mouth. Food is broken down into smaller pieces. The smaller pieces mix with saliva and become a soft mass. The salivary enzymes change some of the starch into smaller sugar molecules. The soft mass of food is swallowed and passes quickly through the esophagus into the stomach. When food is swallowed, it moves from the mouth to the throat down to the esophagus. In the esophagus, food is pushed down to the stomach by ring-like muscles, which contract one after another. These waves of contraction are called peristalsis. Peristalsis is an involuntary movement that people have no control over. The stomach is like a bag or a pouch that receives the food from the esophagus. It can hold about 2.37 liters of food. Food is retained in the stomach, where it is churned through the peristaltic movement of the stomach walls. Digestive juices and enzymes, a mixture of hydrochloric acid and pepsin, secreted by the stomach glands, help break down more of the food and change it into a liquid mass. The stomach empties completely in about 2.5 hours. The food is a thick liquid by the time it leaves the stomach. In the stomach, the following changes occur. Pepsin, an enzyme in the stomach juices, changes protein into smaller polypeptide molecules. Movement of the stomach walls partially crushes digested food and thoroughly mixes the food with gastric juices. A soup-like mixture results. Again, through peristalsis, the soup-like food enters the small intestine, a tube which is 6 to 7 meters long. The first part of the small intestine is the duodenum. Here, the liver, pancreas, and tiny glands along the intestinal walls pour their secretions onto the food. Enzymes from the pancreas and intestine help break down proteins and carbohydrates into small molecules. These molecules can be absorbed and used by body cells. On the other hand, bile from the liver helps in fat absorption. From the duodenum, food moves to the next portion of the small intestine. Here, the bulk of digested carbohydrates and proteins, water-soluble vitamins and minerals are absorbed. The remaining nutrients are pushed to the third portion of the small intestine. It is in this portion where fats, fat-soluble vitamins, and bile salts are absorbed. Absorption takes place in the small intestine. Its inner wall is made up of thousands of finger-like projections called villi. The villi contain tiny blood vessels and lymph vessels into which the absorbed digested food goes. The blood carries the food to different parts of the body. In the small intestine, these changes happen. Bile produced by the liver and stored in the gallbladder breaks down fats into small drops. Enzymes from pancreatic juices and intestinal juices change food molecules into small absorbable molecules. Fats become glycerol and fatty acids. Proteins and polypeptides become amino acids. Starch and bigger sugar molecules become simple sugars. Solid food that enters the mouth has been changed to a soup containing absorbable molecules of sugars, amino acids, fatty acids, glycerol, and water-dissolved minerals, also vitamins. Food molecules are absorbed through the villi into the bloodstream to be distributed to different parts of the body. Not everything in food can be broken down or digested. What happens then to the undigested food after digestion? The undigested material, together with some fluids, pass down into the large intestine. It measures 1.5 meters long and is identified in sections. The first 1.37 meters is called the colon, then followed by the rectum, and then the anus. In the colon, more water is extracted from the liquid mass. This mass is thickened to form feces. The waste material remains in the large intestine for 24 to 48 hours before it is propelled by peristalsis into the rectum for excretion through the anus. Now, if you eat fruits and vegetables, much of it consists of fibers, which is the undigested food. People are surprised to know that fibers are important precisely because we cannot digest them. Fibers are important to a person's diet because fibers provide the bulk to the feces, absorb water, and make the feces soft. It is easier to move the bowels if there is a greater volume of waste with soft consistency. Many doctors believe that a high-fiber diet protects a person against cancer of the colon and rectum. And it is believed that fibers lower the level of cholesterol in the blood, thus lessening the risk of heart disease. Aside from the solid wastes or feces, other waste materials have to be excreted out of the body. The urinary system, sweat glands, as well as the respiratory system help rid the body of waste. The kidneys are important organs of the urinary system. They are two reddish-brown bean-shaped structures, one on each side of the spine, just above the hip bone. Each kidney contains about 1 million filtering units called nephrons. Nephrons are microscopic structures or renal tubes which purify the blood by filtering out the toxic waste products that form urine. Urine travels from the kidneys through the ureters, leading to the urinary bladder, which is the storage organ of urine. The urinary bladder contracts when it is full, pushing out the urine through the urethra and out of the body. You must have heard of the dialysis machine. The dialysis machine can be used as an artificial kidney for people whose kidneys fail to function. The blood from an artery of a patient is allowed to flow through a tube into the dialysis machine, which filters out the waste products. The purified blood is then returned to a vein of the patient. Food molecules distributed to body cells are broken down to release energy in a process called respiration. A waste product of respiration is carbon dioxide. Carbon dioxide leaves the body through the respiratory system when you exhale. This will be discussed in greater detail in another episode. In summary, here are some things to remember in today's lesson. Food that enters the body is changed into a form which the body can use. This function is done by the digestive system, which is composed of the digestive tube and associated glands and organs. As food goes to the different parts of the digestive tube, it undergoes mechanical and chemical changes. Digestion is completed in the small intestine, and from here, digested food passes principally to the bloodstream by diffusion through the villi. Food is then carried by the blood to the different parts of the body where it is absorbed and utilized. Undigested food, on the other hand, leaves the body through the anus, which is part of the digestive system. Waste products of cell metabolism are excreted through the urinary system, respiratory system, and sweat glands. Most important of all, let us make sure we have a balanced diet, complete with lots of proteins, carbohydrates, fats, and food rich in vitamins, minerals, and fibers. And don't forget the value of washing hands before meals, eating clean food, and proper preparation of food that has to be inculcated in your children. See you again next time. This is your host, Lourdes Carale. Goodbye. We live at the bottom of a vast ocean of air. The atmosphere completely surrounds the Earth, and although it exists as a very thin layer compared to the size of our planet, the atmosphere is important to us and other living organisms. Without it, there will be no life on Earth, as there is no life in other planets. This is why humans carry their supply of air when it is in inadequate amounts, when they go down to the depths of the ocean, when they scale high mountaintops, or when they soar to outer space. Everybody experiences the need for air. Let us watch this group of children.
Ito, tunay na kwento tungkol sa isang tao na nakayanang hindi huminga ng napakatagal. Siya ay si Robert Foster, taga California. Lumubog siya sa swimming pool at nakayanan niyang hindi huminga doon. Hulaan niyo kung gaano katagal siyang hindi huminga.
Hindi ko alam eh. At ikaw, alam mo ba?
Oo! Ako pa, nagbabasa ako ng libro. Lumubog siya sa swimming pool at nakayanan niyang hindi huminga ng 13 minutes at 42.7 seconds.
Aba, napakatagal naman nun.
Kayo, kaya niyo bang hindi huminga ng matagal?
Aba, oo. Pag sumisisid na ako sa swimming pool, nakakayanan kong hindi huminga ng napakatagal.
O kung gusto niyo, contest tayo sa patagalan ng hindi paghinga. Sige, ako muna magta-timer. Sige, 1, 2, 3. Ang hirap. Parang puputok ang dibdib ko.
Teka, bakit nga pala tayo kailangang huminga?
May tanong din ako. Alin ba sa gas sa atmosphere ang kailangan ng ating katawan? Ito naman ang tanong ko. Pag ako ba ay humihinga, saan nagpupunta ang hangin na hininga ko?
Pupils ask many questions about our need for air and what happens to the air we breathe. The present episode will address the following questions. What gas in the atmosphere is needed by the body? What gases do we inhale, exhale? Why does air enter the body when we inhale? And what happens to the air we inhale? Why do we breathe faster when we exercise? Before we proceed, answer the 5 questions on a sheet of paper. Then go back to your answers at the end of the episode and see if there is a need to revise them. The atmosphere is a mixture of many gases. The components of the atmosphere are shown in the pie chart. What are the major components? The air is about 78% nitrogen, 21% oxygen, and 0.03% carbon dioxide, plus traces of other gases. These are the gases you inhale. Which of these gases does your body need? You can check your answer by comparing the amounts of the gases in inhaled and exhaled air. Exhaled air contains about 78% nitrogen, 17% oxygen, and 4% carbon dioxide. Many people believe we breathe in or inhale oxygen, and we breathe out or exhale carbon dioxide. But you have seen that the same mixture of gases is present in inhaled and exhaled air. It is the amount of oxygen and carbon dioxide that differs. Indeed, there is oxygen in the air we exhale. In mouth-to-mouth resuscitation, you breathe out firmly and gently into the victim's mouth several times. It is mainly the pressure of the air you blow that expands the lungs and stimulates breathing. But the oxygen in your breath also plays a role in causing the victim to start breathing again. This is also one of the reasons why people can make glowing pieces of wood burst into flames by blowing through ihip or bamboo tube. Aside from blowing off the ashes covering the smoldering ember and thus exposing this to the atmosphere, oxygen, also present in exhaled air, causes the wood to inflame. We will observe what happens to our chest when we inhale and exhale. We have requested some children to demonstrate an exercise. Okay, children, are you ready?
Yes, ma'am.
May I request Rainier to please stand up? Take off your shirt, please. All right. Now, you are going to inhale and exhale slowly and repeatedly. Inhale, exhale. Inhale, exhale. You may sit down now. Did you observe the movement of his chest when he was inhaling and exhaling?
Yes.
All right. What happens to the chest of Rainier when he breathes in or inhales?
The chest moves outward.
All right. Now, what happens to Rainier's chest when he exhales or breathes out? Rachel?
The chest moves inward.
This is an exercise which you can try in your own classroom. You can tell your pupils to inhale and exhale repeatedly. Then, you can instruct them to illustrate how their chest moves when they inhale and when they exhale. We will now make a lung chest model with the help of my co-teacher, Mr. Edmond Rosales. What materials do we have, Edmond?
In making an improvised lung chest model, we will use the following materials: a plastic jar, a plastic sheet, a white tube made from old transparent ball pen, 2 small plastic bags, rubber bands, and a pair of scissors.
Edmond will now demonstrate the steps as I give the instructions for every step. First, the plastic bags are placed at the end of the white tube. They are held in place with a rubber band. Second, the white tube is inserted into the hole at one end of the jar. The white tube is secured in place with a masking tape. Third, the open end of the jar is covered with a plastic sheet. The sheet is again held in place with a rubber band. To make sure that the jar is airtight, it is sealed with masking tape. To serve as handle, stick a piece of masking tape in the middle of the plastic sheet. Fourth, this is how the lung chest model looks like. The plastic bags represent the lungs. The jar serves as the chest. The plastic cover represents the diaphragm. Fifth, to use the model, pull the plastic sheet downward. Push the plastic sheet upward. Do this repeatedly. What happens to the lungs when you pull the plastic sheet downward?
When we pull the plastic sheet downward, the lungs inflate or expand.
Then, what happens to the lungs when you push the plastic sheet
When we
upward?
push the plastic sheet upward, the lungs deflate or shrink.
Can you tell us why this happens to the lungs?
Air moves from an area of higher pressure to an area of lower pressure.
Thank you very much, Edmond. We'll have more on the respiratory system when we come back. When you inhale, your ribs move up and out, your diaphragm flattens, the chest cavity expands. The diaphragm is a sheet of muscle dividing the chest from the abdominal cavity. The space inside the rib cage becomes bigger, and the pressure inside the lungs becomes less. Air then moves from outside into the lungs. But when you exhale, your ribs move down and the diaphragm curves upward. Your chest cavity becomes smaller. Air pressure inside the lungs increases, forcing air out of the lungs. These are the parts of the respiratory system. This is the nose, and these are the pharynx and the voice box. This is the windpipe or trachea. It is a tube that divides into two tubes called bronchi that enter the lungs. These are the lungs, and in the lungs, its bronchus further divides into smaller tubes ending in air sacs. Let us describe how air travels inside the body. When we inhale, air travels to the nose down to the throat or pharynx. From the throat, air moves down through the windpipe and bronchi into the lungs. In the lungs, air passes along the smaller tubes to the air sacs. In the air sacs, oxygen diffuses from the lungs to the blood in the capillaries. Oxygen in the blood goes to the heart, where it is pumped to the different parts of the body. Body cells use this oxygen and in turn produces carbon dioxide as a waste product. This gas passes into the blood, which carries it back to the air sacs of the lungs. When we exhale, carbon dioxide, together with other gases our body did not use, move from the air sacs to the small tubes, up through the bronchi, windpipe, and throat, and out through the nose. Maybe you are wondering why oxygen is so important to the body. Oxygen is needed by our cells to break down the food we take and release energy stored in it. The released energy will now be available for use by our cells. This complex process is called respiration, which consists of about 40 different steps. It occurs in each individual cell in the presence of oxygen and is represented by the following summary equation. Glucose plus oxygen produces carbon dioxide plus water plus energy, which is released from food molecules. This released energy is now available to the cells so that they can carry out various functions. Breathing keeps us alive. Oxygen in the air we breathe is used by our body cells to release energy in digested food. Our body cells need energy to perform various functions. However, breathing can be dangerous nowadays. We'll tell you how right after this. First, people smoke cigarettes, causing harm to their body and to non-smokers who inhale the cigarette smoke. Dangerous chemicals in cigarette smoke damage tender surfaces inside the lungs, causes increased production of mucus in the lungs, may lead to bronchitis, emphysema, and lung cancer, damage the heart and blood vessels. Second, people pollute the air with smoke coming from motor vehicles and factories. And third, some people sniff glue, paint, thinner, and other solvents.